Hi, my name is Ellen Burns, and I'll be walking you through this experiment that teaches us about the fundamental principles of neural activity. We can look at conduction velocity, refractory periods, both absolute and relative, using the earthworm, which is an inexpensive and relatively easy dissection. Possible experiments include looking at habituation and the influence on conduction velocity done by temperature, ions within the media, and even anesthetics. We begin by placing the earthworm in 10% ethanol to anesthetize it. You can then remove the earthworm after it stopped moving and dab it dry. Then put it in the dish, and you'll have to pin it along the outside perimeter because it's too long. You want to start by pinning down the head, but not the tip of the head, because we'll have to use that for stimulation later. You want to do one to each side of the worm so that we can avoid hitting the ventral nerve cord that's underneath. And you'll want to put the dark side of the worm facing up. As you pin it down, you'll want to stretch out the worm. We'll then take the dish and place it under the microscope, and we'll want to make a 4 centimeter long cut just beneath the clitellum. This here is the clitellum. So we'll be making a cut along the side to avoid hitting the nerve cord. You want to stay very shallow. You'll then take a cut across the body so that you can peel it back. At this time, you want to add some saline while peeling the skin back a little. And you'll want to peel the skin back, and you'll have to disconnect the ligaments that are holding the skin to the GI tract. You want to be slow and careful so that you don't nick the GI tract open. You can pin the skin back and then carefully try and break the rest of the ligaments that are holding the gut underneath with not poking too hard or too far under, or else you'll hit the nerve cord. You may have to rotate the dish to get the ligaments on the other side. Once it's loose, you can try and lift it up and pin it away. Again, being careful to not puncture the GI. After moving the GI tract to the side, you can see the light coloration of the ventral nerve cord. You'll then take the prep to the Faraday cage and wax it down underneath the microscope. We'll then take our electrode and position it near and put the ground wire in. And you're going to need to again pull in saline to the silver wire. And then you'll position the electrode close to the nerve cord. And apply a small vacuum to suck up the nerve cord while looking into the scope. The recording electrode is connected to the head stage, which is in turn connected to the amplifier, which you can turn on, and you'll follow the lab manual for the specific settings. That is connected to the A to D board, which will record into the lab chart 7. On the computer, you can open up the lab chart 7 and follow the protocol in the lab manual for setting up the experiment. You'll want to record a baseline, and then we can check the sensitivity on the earthworm by pushing on the head or the tail to see the difference of the spikes in the electrical recording. You can use a pencil or a glass probe, but you won't want to use a metal because it will pick up electrical noise. For the second part of the experiment, we'll be opening up a second area of dissection so that we can simulate from the head section that we just recorded from and collect recordings from the lower section by the tail so that we can take a look at conduction velocities. We've now opened up an area by the tail the same way that we opened it by the head, following the same procedure. We'll then cut the ventral nerve cord here towards the head and here towards the tail, so we'll have this long length of the ventral nerve cord for calculating the conduction velocity. We'll now place both the stimulating electrode and the recording electrode into the saline and pull saline up to the silver within the tip again. If the tip is too small and has trouble sucking the nerve cord into the electrode, you can change to a smaller tip and perhaps even add Vaseline to the tip to help create a tighter seal. You'll again follow the lab manual instructions to set up your program software. You can either use a stimulator for stimulating the prep, or you can use the internal stimulator found in the A to D board. that will be used within the software. For stimulating, we'll be using the scope software. We can now take a look at conduction velocities by stimulating the head and recording from the tail. We try to recruit both the lateral and medial giant axons, and you can look at the literature to see which are which within the recording. They both give large spikes. Also, while in the setup, you can take a look at absolute and relative refractory periods by giving 2 simulations and following the procedure. You can then change out the saline with a colder saline solution or using different ion concentrations to see how that influences conduction velocities. With this experiment, I've showed you how to complete the dissection, measure responses to stimuli in both the head and tail, measure conduction velocity with temperature, and measure refractory periods. This protocol was developed with help by Dr. Hartman in Oregon. Have fun with your experiments in the lab.